Hey everyone, Mr. Newman here, and today we're going to show you how to do all the problems on the Unit 5 review packet. So, let's get started. One of the things I'm going to do is I'm going to show you how to do some of the problems multiple different ways, just so you have lots of different resources you can get to. If you forget or mess up on one, you can do it a different way or check by doing it a different way. This first one, you can graph those on a graphing calculator. So type each of those into y equals, and you get 3 graphs, and you can match which is which. If you don't have a graphing calculator, if you don't feel comfortable doing that, you can plug in a number and check. So for example, if you plugged in 0, f of 0, then you would get, well, let's see, that whole first thing would be 0, because 0 squared is 0, and 2/3 times 0 is 0. So that whole thing would just be 3. The second whole thing would just be 1, and the third equation would just be -3. On the graph, you can see right there, that point, and that point are at -3, 3, and 1, so you can just match which is which. So we have B, C, and A would be the order of those. A third way to do it, however, is using the vertex formula, which I showed you guys, and that's H comma K is the vertex. The nice thing is on all of these, it's 0 is the H part of the vertex, so you're just looking at that K value on the outside, and that's kind of similar to what we did on number 2. So match those up, and you could plug in more than just 0. You could plug in other numbers, but 0 is just the easiest of the ones I saw to check. Now for number 4, we have x squared equals 256. This is a standard square root problem. So square root of x squared, and don't forget to write the plus or minus. Notice some of the answers have it not written there, so you want to make sure you remember there are 2 solutions. So x equals plus or minus 16. The plus or minus means positive 16 or negative 16. So C is the correct answer. For number 5, there are a few ways to do this. First thing you need to do is you need to get the equation equal to 0 in order to use the quadratic formula. That means I'm going to subtract 5 from both sides first. I can already see people messing up by not getting that equal to 0 and assuming that C is positive 5, but nope, C is negative 5. We're going to plug it in. I would recommend using this trick here. Notice this is the quadratic formula, but I went ahead and wrote down parentheses in each of the spots. This helps remind you that you need to be putting parentheses around each of the values. So go ahead and do that, and then you can fill in A, B, and C where you need to go. So there's B, there's B, there's A, C, and A. You type in the thing in the square root, you get 76, and that is not simplifiable. Sorry, it is simplifiable, and you have to be careful about how you do this. So 76 is 4 times 19, so I'm going to write it root 4 times root 19. The square root of 4 is 2, and you notice at this point, I can actually divide a 2 out of all the things on top and a 2 out of all the things on the bottom. So I divide that out and I get -2 plus or minus the square root of 19 over 3. Now, most of us in this class, we worked on getting to this stage and ending there. And so if you get to that point and you get stuck, one of the things you can do is you can type that, what I just circled in red, in the calculator. And you can see, okay, which of these values is closest. So you could type that in the calculator, type that in the calculator, type that in the calculator, and see which of these is most similar to the quadratic formula you got. Unfortunately, you have to type that in and check if you don't know how to simplify the radical on the right here, as I did. Now, here's a backup plan. If you fail or forget to use the quadratic formula, you can graph it. So, how do you do that? Well, first you plug into y equals, and then you find the zeros using second trace, and these are the 2 zeros. Remember, I have that set of videos for you to watch if you forgot how to do that, so I'm not going to rehash that now. And you notice this does not give us an exact answer. The answer choices are exact answers. So if you're going to use the graph it method, what you have to be able to do is, well, you can look and see it's not going to be A or C. It might be B or it might be D, and I can't look at those and just tell. So what you're going to have to do is you have to plug those into the calculator. I want to show you guys how to plug it in, because a lot of people ask me, well, how do I plug in the plus and minus? You don't plug in plus minus. You plug it in twice, once with plus and once with minus. Okay? So that is how you plug in answer choice B, and notice how answer choice B looks exactly like the two that are on my calculator there. You'll want to write those down. And so answer choice B is the correct answer. You should also get the same thing when you plug in the final answer down there on the bottom right, or this midpoint here. All those should be the same set of numbers. And remember, you don't plug in plus minus, you plug in plus once, and then you plug in minus again separately, as I did down here on the calculator. All right, so the next one, you have lots of ways to do this. Perhaps the fastest is factoring, so I'm going to actually do it that way. Notice the GCF is 3, so I'm going to factor that out first. And then I need to do factors of -20 that add up to -1. So I'm searching here, got some factors, and aha, those two add up to -1, so I'm going to stop there. The way I do it, I use box method, but there's lots of different ways to do that. I separate that middle term, and I get x plus 4 times x minus 5. Now I set each of those factors equal to 0 and solve them. And I get x equals -4 and x equals 5. Notice the difference between that and your initial factors. A lot of people like to stop right there at -5 and 4 and go, I found them, there are my answers. Be very careful you don't do that, because the zeros, remember, have the opposite sign, or seem to have the opposite sign of the factors. So make sure you finish that problem all the way through. A second way to do this is you could use the quadratic formula. I'm not going to do that now because we just did, but you could use 3 for A, -3 for B, and -60 for C, and you would get these two answers in the quadratic formula. Another way you could do this is you could also graph it. 4 and 5 would both show up on your window, so you would be able to see that -4 and +5 are the correct answers by looking at the zeros on the calculator. Yet another way to do this is guess and check from the answers. So you see there's only 4 answer choices. If you want to be careful, because, for example, if 5 works, A or C could be an answer, right? So you just want to check 4, 5, -4, or -5, and see which of those two values gives you a 0, where you plug it in here and it gives you a 0, and then that would be one of the answers. All right, number 7. Christiana just tries to find the zeros of the quadratic function. A of x equals -2x squared minus 4x minus 3. She used the discriminant and decides that a of x has no real zeros. What is the value of the discriminant for a of x, and why does it show that it has no real zeros? Just a reminder, the discriminant is found under the square root symbol in the quadratic formula, so it's b squared minus 4ac. If that number is bigger than 0, then we have 2 zeros. If that number is less than 0, we have no zeros, and if that number is equal to 0, we have exactly 1 zero. So I'm going to write those into b squared minus 4ac and calculate it. When you do that, you get -8, and I would recommend, so that means the discriminant is -8. I would recommend just typing that first step in there in the calculator, and you would get -8. And what does that mean? Well, when the discriminant is negative, we have no zeros. That is why it shows it has no zeros. And that simple explanation is enough to show that you understand what's going on. Number 8. A person is standing on a roof 30 feet in the air. He throws a rock with an upward velocity of 40 feet per second. Use the formula h of t equals -16t squared plus v0t plus h0, where h of t is the height above the water, t is the time, v0 is the starting upward velocity, and h0 is the starting height. What is the maximum height of the rock, and after how many seconds will the rock hit the ground? Well, what I'm going to do is, this is a calculator problem. I'm going to plug that into the calculator. Notice v0 is 40 and h0 is 30. I got that from reading the paragraph. So I type in like this. A lot of people miss this x right here. Don't miss that x, okay? When I plug it in, I get this graph, and I'll have to use the second calculate maximum feature in order to find the maximum. Notice this graph goes way, way, way up there, and the maximum is, it's a big number, it's 1.25, 55. But I could also use the feature of typing in numbers when I have to do left bound and right bound, because I know it's going to be somewhere between 0 and 3, or -1 and 3. So when it asks left bound, you can just type in -1, enter, and right bound, you type in 3, enter. And then for a guess, you can just press enter again, and your calculator will find that maximum for you. So 55 feet is the maximum height of the rock. So you could graph it. Another way to do that is if you find the zeros, you find those from the quadratic formula, and then you find halfway between the zeros, that's a plus b over 2. That will give you the x value, that will give you 1.25, and you can plug that into your equation and get 55. That's another way we practice doing that, but you can either use a calculator or you can use that method. For part B, what you want to do is you want to find the 0. Again, that would be second trace and go to 0. Again, you're going to do left bound, right bound, and then guess. And right there, that is our 0. So 3.1, about 3.1 seconds is when it'll hit the ground. Likewise, if you did the second method and you found the zeros, you would have already had those two numbers and just recognize that the positive number of the two zeros is the one you want to use. Number 9. The roots of a quadratic function are -2 and -7. What are the two factors? Remember that if you have -2 as a factor, as a root, x plus 2 is the factor. -7 is the root, x plus 7 is the factor. So in order to write the function in standard notation, what you're going to do is you're going to multiply them out. And I did that right here in the Punnett square box for you. We'll combine 2x and 7x, the like terms, to get x squared plus 9x plus 14. Two things, I'm going to go ahead and plot my two roots, my two zeros, -2 and -7. The vertex is on the line of symmetry, the axis of symmetry, and that's halfway between those points. I know that's -4.5. So if you add those two together and divide by 2, you get -4.5. To get the y value of the vertex, though, I'm going to need to plug that back into the equation. So I write down my equation there with the x's being blank, and I'm going to plug in -4.5. When I do that, I get -6.25, so there is my vertex, and I plot that point. Then I graph the function, and here's where you can go ahead and type this into your graphing calculator, and you can get a table. And I would plot the points first and then connect the dots. It makes it much, much, much easier. But you can go watch that video. I have that set of calculator videos if you forgot how to use a table to get these points. So here are all my points that I'm going to use. I'm going to plot them right there, and I'm also going to, you can also type in -8 and -1, and you would get, they both have a y value of 6, and plot those points. And now it's just a matter of connecting the parabola I have outlined here. All right. So, number 10, graph the following function accurately, and that means plot at least 5 points first. So I'm going to follow much the same trajectory. If you do factor this, which you can do and take your own time, you get x minus 5 and x plus 1. That quickly finds me two zeros, x equals 5 and x equals -1. Now I can identify the axis of symmetry as halfway between those. Halfway between -1 and 5 is x equals 2. The vertex then must start with a 2 and be something else. So I'm going to go ahead and write down some of these points. 2, comma, and we plug in 2 to get the y value of the vertex. It's -9. So 2, comma, -9 is my vertex. Now, I did all this by just by algebra. You could work from the other direction. You could type it into the graphing calculator and work backwards and find your zeros and your minimum that way as well to get the vertex. And remember that the axis of symmetry is always the x value of the vertex. When you plug in 0, well, let's see, I get -5. When I plug in 3, I'm just picking points to fill out the area, I get -8. And look, do you see the points I chose? Because that's the line of symmetry, or the axis of symmetry, if 3, -8 is a point, that means 1, -8 must also be a point on the parabola. Likewise, with 0, -5, I can flip that over the axis of symmetry, and I get 4, -5. And that helps me quickly find some other points that are part of the parabola that I can plot. So I connect those and we get our parabola. For this last one, we're going to just fill in the blank for each of these. The domain of all these parabolas is always negative infinity to positive infinity. The range is going to be basically 4 down, but remember I need to write the smaller number on the left, so negative infinity, comma 4. Negative infinity is not included, but the 4 is included, so I need to put a bracket on the right, but a parentheses on the left. The function g of x has zeros at the point. Well, there are my zeros, negative 3 and 1, so I need to write them as points, negative 3, 0, and 1, 0. The function has a y-intercept of 0, 3, so 0, 3 there. And that is a maximum, and that point is negative 1, 4. The axis of symmetry, it goes right through that maximum, so x equals negative 1. And the increasing interval here, you have to remember that you use the x values for increasing and decreasing interval. So we go from negative infinity all the way up to negative 1, and the decreasing interval going down, we go from negative 1 all the way to positive infinity. And that is also using the x values. Remember, x value on the intervals. Last question, I'm going to actually plug that into the graphing calculator, and you notice one problem is it goes off the bottom. You can actually zoom out using either window or zoom and then out and press enter. And when you do that, you can actually see the whole thing, but we don't need to see the whole thing. We can do this just the way we have it, because we know that the domain is going to be negative infinity to infinity. And right here, I plotted it, and I found it. I didn't actually graph it, though, but I sketched it what it should look like. The minimum down there is going to be at negative 3, negative 16. And I used the find a minimum feature of the calculator to get that. So that means that the range is from negative 16 up to infinity, with a bracket on negative 16. There are zeros, you see I found the zeros here at 1 and negative 7, so 1, 0 and negative 7, 0. There's a y-intercept, I did not show the graph of that, but if you type in 0, you get 0, negative 7. And the function definitely has a minimum, and that minimum is at the point negative 3, negative 16, as you see from the bottom right screen of the calculator. The axis of symmetry will go through the x value of the minimum, so x equals negative 3. And lastly, the increasing and decreasing intervals, remember we have to use negative 3, our x value, as our reference. So the increasing interval is on the right, that's from negative 3 all the way up to infinity. And the decreasing interval goes from negative infinity all the way up to negative 3. Thank you very much for watching.